Welcome to session 7 of our bootcamp on trigonometric functions. And as usual, I will share my screen. Please let me know if you can't see it in the next couple of seconds. Hopefully it's coming on now. Yeah, there we go. All right, I've lost it on here with the chat. Give me 1 second. In the meantime, here is your warm-up question. So what is the standard form of a trigonometric function? That's question A. And question B, what is sine of 0 and cos of 0? These I recommend you knowing just at the top. I'm combining two things, at the drop of a hat or at the top of your head. Is that the same? Anyway, you should just know these. So I just need to find the chat again. While I do that, please answer the question in the chat. There we go. Got it back. So for this session, we are going to be doing kind of the basics of trigonometric functions. So they can be a little bit confusing, and the questions, especially applying them to real life situations, they're almost always asked as a real life situation, like a Ferris wheel or the tides or temperature, or like hours of the day. So things that are cyclical, things that go in cycles. They follow like a sine wave or a cos wave. And I'm going to be doing the intersection of the 4 courses. So AI, SL and HL, AA, SL and HL, they kind of ask things a little bit differently. And AI SL doesn't include the phase shift. We'll go through what that is, but I will try and note when it applies to, or when it doesn't apply to AISL, just for those who are doing AISL. So maybe to start off with, just so that I know, or actually, no, I think it's gonna, it doesn't matter. So any answers in the chat? What is the standard form of a trigonometric function? To show you an example of standard form of something, what I mean is like the general form. So like a quadratic has this as a general form. So what is it for a sine or cos function? All right, we'll answer that in the next couple of slides. And sine of 0 is just 0, and cos of 0 is 1. So these are ones that are just good to know. They help save time, make things easier, and they're going to get asked so many times because when things are 0 and when things are 1, they really help simplify equations that we're solving or questions that we're answering. So it's great to just know those immediately. Cool. Right, so let's just look at what we have. By the way, this is not in AISL, no tan, so don't worry about that. But if you're in AA, you need to know all 3. So we have a sine function following this wave, very important, starting at 0, 0. It repeats over 360 degrees. So every 360 degrees, you get 1 sine function, or 2 pi. Again, radians. Anytime I speak about pi, that's not in AISL. You don't do radians, but you can apply what I'm saying to degrees as well. So it shouldn't be a problem. Then we have cos starting at 1, not 0 like sine. So that's often a big clue of when it's a sine graph or a cos graph. And then a tan graph, repeating every 180. So you can see there is 1 part and there is 1 part. So that is a whole tan graph. Like these are a whole cos wave or sine wave. Well, this is the whole tan wave, not really a wave, but so it repeats every 180 degrees or every pi. That's important to know for our trig equations solving as well. So important facts. We have, like we said, the period is how often it repeats. So how often does it do a wave? So that was every 2 pi or 360. Same for a cos. Oh, that's an ugly cos graph, but every 2 pi or 360. The amplitude is this height here. So if we cut it in half, the height is the amplitude. And for a standard cos and sine graph, it is 1. Same here. If we cut it in the middle, this distance, they're both 1. That's amplitude. It's just taking a half of it. We already talked about the intercepts, minimums and maximums. They go from, because the amplitude is 1, they go from 1 to -1. So if you're getting something like sine x equals -2, that's just not possible because the lowest it goes is -1. Same for a cos graph. It's also -1 and 1. However, a tan graph is going onwards and upwards and downwards for infinity in both directions. So the domain of a tan graph is all real numbers. Basically, it can take any value on the domain, whereas sine and cos, on the range. But yeah, the sine and cos graph are only between -1 and 1, and I'm meaning in terms of range, sorry. So these are just a couple of things. Symmetry, we're not going to talk about too much, but we essentially have that the sine graph is rotational about the origin. So, symmetrical about the origin, whereas the cos graph is symmetrical about the y-axis. So if we look at the cos graph, it's going to go like this. So if you folded it over the y-axis, it would be the same. We call that an even function for the HL among us. When it's symmetrical about the y-axis, that's an even function. And this one, symmetrical about the origin. So that gives us these values that we will use, but not so much in SL. All right, important to know the key coordinates. Like I was saying at the beginning, knowing that a sine graph goes through 0, knowing that a cos graph goes through 1, and I would say these points, that one, so 0, 0, knowing that at 180, this is 180 here, excuse all the pi, this is 270, and that's 360. Knowing all of these sort of key intercept points, I think is really helpful. Knowing that at 90 degrees, it's 1. So being able to sketch a little, oh no, this is, I'm not going over a whole one. There's my whole sine graph. We've gone more. Ooh, there we go. So that's 180, this is 270, and this is 360, ending with that wave. So knowing these things, like 270, sine of 270 is going to be -1, sine of 90 is going to be 1. These are really helpful to memorize. Or just to be able to do a quick sketch of a sine graph, then you can easily get those values. And the same for cos. Then the tan function, AISL, it's not in AISL, so you can zone out for a second. Our tan graph is made out of sine x divided by cos x. We have that identity that we work with. Therefore, there are certain values that we cannot have in the denominator, i.e. we can't have this equaling to 0, which is what gives us these asymptotes here that our graph is never going to be at. So that's where our tan graph comes from. All right, so my question at the beginning was asking about the general form or standard form of a sine or cos graph, and here it is. These are our parameters. So we have A for amplitude. We already talked about that. That's half of, like, we have our graph going like this, then amplitude is half the distance of the wave from top to bottom. That is our amplitude. Then we have D, that is our principal axis. And that is halfway between our graph. So in this case, it's y equals 0. The axis, we give y equals 0. That's the line that cuts the graph in half. Also, the vertical shift. So however much we've moved the graph up or down. So D, vertical shift up or down. C is horizontal shift, so left or right. This is also called the phase shift. Might be referred to as the phase shift. SL, AISL, you don't need to know phase shift. So for AISL, it looks like this. You guys have A sine B just X plus D. So you don't have the C, basically. You just go straight with that. So you'll only be working with A, B, and D. But for AA and AIHL, then you do need the phase shift. So that's just left or right. This is up or down. B is our period of the graph. So how long it takes to repeat itself. All right. And we're going to be calculating that with some formulas. So to find B, you do well, we'll come to that later. I don't want to overload you. All right, so these are just different transformations we can have. Stretching, so A is going to be the stretch thing, depending on if what number A is. It could stretch it like vertically or like out like that. Translations, that's our C and D, up, down, left, right. And then we also have reflection. So we could reflect it. If this is negative, we're going to fold the graph over. And it's exactly the same for cos, just with cos instead. So I just wanted to show you this. I had it on, no, where was it? On Exam Dojo on Learn, if you go to this interactivity. So here I have it. It's for AISL, but there'll be one in AISL as well and the HLs. But it's really cool just to be able to go and look at what these different transformations do. So if I start with that's my normal graph for the amplitude to see how that gets affected. What do you think will happen if I increase my amplitude? What is my graph going to look like? Well, right now the amplitude is 1. So now if I make it 2, can you see how it goes up to 2 and minus 2? And if I make it a half, it's going to be more squashed, like more flattened. And now my amplitude is just a half. So this is quite nice to play around with to be able to see. For example, this is the normal period of the graph. So it's going for 360 degrees. But what if I halve the period? What do you think it's going to look like? And it's actually going to get stretched out. Whereas if I make B equal to 2, there's going to be many more cycles within one of those waves. We can do the same for cos and also for tan. If we increase the amplitude of tan to 2, it gets a bit straighter, whereas if it's a half, it's a bit curvier. To answer your question about, are you sure it's for AISL? Yes, so it's actually not in the geometry and trigonometry topic, but you'll find it in functions. So if you look for AISL in functions and then, what is it called, modeling, then it's everything that you need for sine and cos. It's not in the geometry and trigonometry section, but in the function section. So you can change these things. Translations as well. This is an interesting one. Let's say I have C equals pi over 4. I'm going to shift it. Wait, there's, I'm going to sneeze. No, okay. So here it is normally. Now, if I make my shift pi over 4, we're going to move right, pi over 4 units. If I make it pi over 2, I'm shifting it and minus going that way. So that makes a lot of sense. Vertical shift as well. This is our normal. Let's say I want to move it 2 units up. It's going all the way up to 3. So this is just something that I recommend you could look at if you were wanting to understand it a bit more and see what's happening there. Okay, the important things that you need for your exam are these. Most importantly, to memorize, this is something that is not given in any formula booklets. This is for all courses. You need to know this. To find the amplitude, if you have the maximum and the minimum, which often questions will give you the maximum and the minimum, and you use this formula to find the amplitude. So see how similar these two are. This is for the principal axis. Principal axis, that middle of the wave, and amplitude. I would note these down if I were you, add them to your formulas that you have to memorize before going into the exam. We're stacking up with quite a few in these sessions of ones that we need to memorize. So the max minus the min divided by 2 gives you amplitude, or the max plus the min divided by 2 gives you the principal axis. When we want the amplitude, remember we want the absolute value, because amplitude is like the distance. So we can't have a negative distance. So even though your question might be like minus 2 sine x, your amplitude is not minus 2. Your amplitude is going to be 2. Then this was the thing we were talking about earlier, the period of the graph. If you want to get the period, then you do 2 pi divided by b. So they might ask, what's the period of your graph? 2 pi divided by b. Conversely, if you want to get b and you have the period, it's just 2 pi divided by the period that you can see from the graph. And for AISL without radians, this would look like 360 divided by b, or say p equals, or b equals 360 divided by the period. So these ones you need to remember. This is for cos and sine. And for tan, it's just pi. Pi divided by b, or 180 divided by b, if you're in degrees. So this is how you can work out the period if you're given b, or find b if you're given the period. And the other ones are horizontal and vertical translations. Can you note that c here is written negative c? So this can be a bit confusing. If I have sine x minus, let's say, 60, minus 60, this actually means, because there's minus in here, this is a positive c of 60 degrees, which means it's actually going to be moved to the right, not the left. You'd think negative, so it means it's going to go to the left, but actually because c is 60, that minus is part of the formula. It's not minus 60. The c is 60, so you're actually going to be shifting to the right. Just like if you have sine x plus 60, this is actually going to be a shift to the right, because what we're saying there is x is plus x is, sorry, no, getting there. X is minus 60 degrees, because in the formula it's minus, so simplified that is plus. So that's actually going to be to the left, whereas this one, it's going to be to the right. So we just have to remember it's that opposite sign. Anything else? Yeah, we can get reflections, but we're not going to spend too much time on that. All right, just a quick example. Say that we had to sketch y equals 3 sine x. The only transformation that's happened is the amplitude. There's nothing that's been altered here, nothing that's been added on. So the amplitude has changed from 1 and minus 1 to now 3. So it goes between 3 and minus 3. That's the only change, the pink graph there, is we've stretched it out. Or this one over here, we have cos x minus pi over 3. For our non-radian friends, we have x minus 60 degrees. So this is, it's minus, so it's a shift to the right. Remember, you think left, but it's actually right. So you can see the graph here. This is the original, and you can see it's been shifted that way by pi over 3 or 60 degrees. That's a shift of that way because it's happening within the x. It's happening to the x. Outside is up or down, but within the brackets, it's happening on the x-axis. Ah, nice. Glad we answered the question. So just to show you, sometimes you're going to get a graph that they don't give it to you in the standard form. And by standard form, I mean this, the y that I showed you, a sine b x minus c plus d. That was our standard form. And they might give it like this. So when you are looking at this, you can't just read off things. You can't just say that that is c, because it's not in this form. So we have to change it into this form. Again, this is not for AISL. Apologies, AISL, but you're also lucky that you don't have these. It's a bit nicer, but yeah, this is not for you. So they'll not give it to you with C. If we want to put it into that form, well, we don't have an A, so that's fine. We don't need to count for that. And we're not adding or subtracting anything, but we do need to put it into this form. So what we need to do is we need to factor out this 2. So if I factor out the 2, I'm left with x in my bracket. So if I multiply out, I get 2x. That's fine. I need minus, but let's not do that for now. Plus, now 2 times something to give me pi over 3, because I can't just write pi over 3 because I'm going to get 2 times pi over 3. So instead, I'm going to write pi over 6. And that's when I multiply 2 times pi over 6. That will bring me back to my pi over 3. So we've just got to factor out, just like how you factor out usually. All right, but still that's positive and we need negative. So we've got to write this as such, sine 2x, and now it's minus in the formula. So to keep that being what it was, the positive, we have another negative there. There we go. It's a lot of brackets. Do I have enough brackets? We need 1, 2, 3. So one more. All right, and now it is in our standard form, and we can directly read off our A, B, C, and D from this equation. So let's check out what that is. So A is whatever is in front of here. It's just 1, not 0. B is our number in front here, which is 2. C is minus pi over 6. So see, very different from just reading off plus pi over 3. It's actually minus pi over 6. So just got to be careful with that. And D, nothing is being added on. So in this case, D is 0. There we go. So just beware when you see a question like this to put it in standard form. Okay, we are getting to some questions in a moment. There's just quite a bit of theory before. So we're often going to have our real-world models using something like hours, days, seconds, months, all of this being on our x-axis. So not actually just angles and degrees. So usually we're used to having our sine graphs being, or trigonometric graphs having 0 to 360 or 2 pi. But most often in these questions, it's going to be like hours after midnight. So to 24 hours, from 0 to 24, or for 0 to 60 seconds. That's quite normal. Or months, so 0 to 12. These are all the things in life that follow a cycle. And that could have a real world quantity of water depth or temperature on this axis. So not being from -1 to 1, but having things that are more like temperature or height. So to keep in mind that you can't have negative height. You can have negative temperature. You can have, water depth should be positive. That's a distance. Hours of daylight, you can't have negative hours. So these are just things to keep in mind when you're answering. These are going to be on a y-axis when we're answering these questions. All right, thank goodness a question. There isn't a question, but there was something I wanted to show off of this. And I think I wanted to just explain in a real life situation. but I think I'm not because we've been over what these are, like amplitude. No, maybe it's a good idea. So let's just write it out. Amplitude is absolute value, but here in this case, it's still 5, so that we are good on. Now here is our B value. So if I want to know the period from that, then we need to do, are we in, doesn't say if we're in pi or pi, so let's just do 360 divided by 6. We had that from our, here, one of our formulas. 360 divided by b, which is 6. So we get, well, 36 divided by 6 is just 6, so 60. So our graph is repeating every 60 degrees. We have a phase shift of -5, so it's going to be 5 units. It's minus, so that means to the right, 5 units to the right. And plus 10, that means 10 units up. That also means our principal axis is y equals 10, always y. So when we have our graph, what is it, a sine graph? Let's say it looks something like this. Then the axis going through the middle here is at the point as the line y equals 10. This gives us a lot of information, actually, the amplitude and that. A lot of these are going to be really helpful because then if I know that my principal axis is at y equals 10 and my amplitude is at 5, each of these are 5, well then my maximum is at 15 because 10 plus 5, and my minimum is going to be at 10 minus 5, which is 5. So that gives me a lot of helpful information about my graph before we've even started the question. Okay, let's do an actual question. Very small. Let's put that up a bit. Okay, so wind speed is recorded at a coastal weather station, and it follows a 24-hour pattern. So the days, each period is 1 day. So we're going from 0 to 24 hours, and then it restarts again with the next day. I find it quite helpful to kind of draw out what we have already in a rough sketch. So let's say that we are like this, like this. It's a sine graph, important to notice. Let's put in our domain. We're going from 0 to 24, not 360 degrees. So here is our time on this axis. And on this axis, we have the wind speed in kilometers per hour. What else do we know? We know that we have our principal axis is at 12. Let's say 12 is somewhere there. So principal axis at 12. So I'm going something like that. My amplitude is 3. So I should write y equals 12 to fill it in. There we go, cut off a little bit. This distance, my amplitude is 3. And this 2 is 3. So that means we're going up to 15, and 12 minus 3, 9. What else can I tell? It's been shifted to the right 2 units, so that shouldn't actually be joining there. It should be to the right a little bit, but there is a little gap, so let's pretend that's my 2 units to the right. That way, sorry. And the 12 is being shifted up. I prefer to think of the 12 just as the principal axis rather than being shifted up 12. It helps with confusion a little bit to start with that. And the period is 15, or sorry, B is 15, not the period. B is 15, which means the period is 360 divided by 15. Which is it's been a long day. 24. Oh, which of course we knew because it repeats every 24 hours. So that we could just read off the graph or off our axis, 24. But there we go, we've confirmed it. So there we have a few values before we've even started the question. So write down the wind speed at midnight. Well, T is the number of hours after midnight. So we're starting here. This is midnight. So that's where T equals 0. That's midnight. And then here's midnight again once it repeats. So we can substitute for T equals 0. So let's take W of T, which is 0, 3 sine 15 T is 0, minus 2, plus 12. Was that 12? Can't, messed up. Yeah. So 3 sine 15 times minus 2, because 0 minus 2 is just minus 2, gives us minus 30 plus 12. Now, you could put this on your calculator, or you know that sine of 30, sine of negative 30 is the same as saying negative sine of 30. And sine of 30 is a half, so it's negative a half. So sine 3 times a half plus 12. 3 times a half is minus in there. 3 times minus a half is minus 1.5 plus 12. That gives us 10.5. All right, there we go. 10.5 kilometers per hour is our wind speed at midnight. All right, find the minimum wind speed and the time at which it first occurs. So minimum wind speed, we've actually already got this in our graph, but if we hadn't, we would know that the principal axis was at y equals 12. And the amplitude was 3. So to find the minimum wind speed, it's just 12 minus 3. So 9 kilometers per hour. But on our graph, it's really nice and clear when we have our graph. Here being 12 minus 3, amplitude leaves us at 9. So in case that was too fast or you missed that, there we go. There's our minimum value at 9, 12 minus 3. And we need to find the time at which that first occurs. So we also need to know when this is equal to 9. So 9 equals, because 9 is the speed, that's our output. And then we take our function. So 3 sine 15t minus 2 plus 12. So we're working backwards to find t. Now, what you can also do, I just want to show you calculator skills. You can take this as a graph and y equals 9 as a graph and put them on. So let's say, whoop, that's not what I meant. Nope. Graphs. So we could take that graph, which is 3 sine 15. Remember brackets. If you're using the sine function, you need to use brackets, otherwise it won't recognize it. T minus 2. And we can't use t, we have to use x for our calculator. Plus 12. And this question, we were in degrees. Degrees. Don't worry, we need to change our window to match. Okay, so we were between 0 and 24. That was our x, what we wanted to see of the x-axis, 0 and 24. And according to our little diagram, our graph is going from 9 until 15. So let's go from 8 until 16, just so we can see the tops of it. 8 until 16. Much better. So this is giving us our graph. And we wanted to find when this graph was equal to 9. So I can add another graph, y equals 9. And it's going to give me that line over there. And there we go. It's that point over there. So I'm going to do menu, analyze graph, and I want the intersection of these two, and I've just got to zone in on a value. There we go. And that gives me 20. See 9 there, we already knew when it equals to 9. So 20. So the answer here is T equals 20 hours after midnight. That is 8 o'clock. 20 hours after midnight. All right, and we could also solve this. So let's pretend that we don't have a calculator and we need to solve this like an equation. We're just going to move some things around. So I'm going to move 12 to the other side, so it becomes 9 minus 12, which gives me minus 3. Then I'm going to divide by that 3 on both sides, so that gives me minus 1. 15t, oh, sorry, I wasn't meant to put that plus 12 again. I took that away. T minus 2. And now I have to think, I have sine of something. Sine of what gives me minus 1? This is where it's useful to draw a little sine diagram. Sine of minus 1 is over here. Minus 1, 1. This is 360. This is, you can use a calculator if you're in AISL, but for AA, if it wasn't, a little diagram is useful. So here, where we have sine of minus 1, that is 270 degrees. Halfway between 180 and 360 is 270. So now we know that sine of something, when it's equal to minus 1, is 270. So we can say 15t minus 2 is equal to 270. All right, divide by 15, t minus 2 equals 270 divided by 15. Say 300. It's gonna be 18. And add to 20, there we go, which is what we had, 20 hours after midnight. All right, there we go. So that is one way to answer the question. Graphically or by hand, either are fine. Any questions? No, everyone's still going strong. Right. Yeah, let's get into some other types of questions. So again, we have a 24-hour period and we're looking at temperature. Oh, note it's called the period, and we say in English things like over a 24-hour period. So that makes sense. The maximum temperature is 35 and occurs at 2 p.m. The minimum temperature is 15. So note, when they're giving you maximum and minimum, that brings us to our formulas for amplitude. So let me just write those there because we're going to need to find them. Amplitude was max minus min over 2. And what else could we find? D, that was A. D was principal axis. I'm just going to keep saying the names over and over so it gets really clear. That was max plus min over 2. So now we have maximum and the minimum. We can definitely find these two things, A and D. That's half of the battle. B, we already can know because there's a 24-hour period. So to find B, we take, are we working in degrees? Yes. 360 divided by 24. And we get our B, which was 15. So there we go. We have our B already. I'm going to write that on top. B is 15. Let's do our A. Max minus min. So maximum was at 35 and minimum was at 15. So 35 minus 15 over 2 is 35 minus 15 is 10 over 2, which is 5. No, 20 over 2. which is 10. So there we have our amplitude, our A. I'm going to write that on top there, 10. We know that. Write things in as soon as you know them. D, we could do max plus min, 35 plus 15, which is 50. 25. All right, we're finding values here. Now, the only thing we don't have is C. So we need to find C, but luckily we've got all of the other ones and we've been given a coordinate here. We've got, you just take out that. And that's actually getting messy. So we've got maximum is 15 and occurs at 2. So this is a coordinate saying that basically what's our input T? T is 14, and because it's hours after midnight, so that's 14 hours after midnight, and our Y is 35 degrees. So we can put that into the formula. So let's write the formula all together. What do we have so far? T of T equals 10 cos 15, don't know C yet, plus 25. So these are all the things we've figured out already. So now to find C, let's substitute because we don't know. These are all of our variables, T and C, but we have some values for that. So T of T is 35. And T is 14. Plus 25. There we go. So it's just one missing variable there. So we can solve for that. How many marks are questions like these usually worth in AISL? We'll do some of them, but there are a lot of questions in AISL like these. Finding amplitude, finding principal axis, finding the period, and they range from 1 to 3 marks depending on the information that you've been given. So this is a good section for AISL, and these questions actually come up quite often, trigonometry. Even though it's part of the functions, there are a lot of questions that come up with this where you do have to work this out because it is one small part of AISL where you actually do have to do manual working out and not just calculator. So they like to bring these up. All right. If I'm going too fast or if anything is not making sense, then please tell me, and hopefully I'm not going too slowly. So plus 25 minus 35 is going to be 10. 10 cos, a bit laborious, I know. Right, then divide by 10 on both sides, so we get 1. Now we have another situation where we have 1 is equal to cos of something. Again, the of something in the middle here, it doesn't really matter when we're trying to figure out what value it is. So when is cos equal to 1? So again, we like our diagrams. They're super useful to know. 1, hint, hint, and remember it goes down to minus 1. So we wanted when cos was equal to 1. Look at that. Remember that was, I know I said cos of, yeah, that was the thing that I said in the beginning. Cos of 0 equals to 1. So that means here, cos of this whole thing equals to 0. That makes it equal to 1. So we can say that 0 equals 15, 14 minus C. I'm going to divide by 15 on both sides, so it disappears over there. 14 minus C. So C equals 14. And what was I actually, I was finding C. So now I can write my equation all together. T of T equals 10 cos 15 T minus 14, we've just found it, plus 25. Whew, there we go. The next question is to find the temperature at 8 p.m. And I'm not going to do that, but what you would do is just substitute for T equals 20. So T of 20 and substitute 10 cos 15, 20 minus 14 plus 25. And you'd solve it in a similar way. So I'm not going to do that now because we've done one quite like it, but we're just going to solve that. And that's that kind of question. So finally, some exam style questions. These are taken from AA. This is the November 2023 paper. It's paper 1, so no calculator is allowed. However, I've really tried to overlap the questions to be the same style of question. So AISL, it's also going to be a very similar style of question for you. So it's not something you have to zone out for or worry about. This will be the same, basically. Now, consider the function f of x, just going to write it again, equals a sine bx. So see, we're missing c. They're not asking us about c in this question. And we're most likely going to have to find a and b. So they've given us the graph. Already, before I even have to do any calculations, I can see that the amplitude is 7. See, from here to here, halfway through. Amplitude is 7. So I can already write that in. Sine bx. Okay. My principal axis is at 0. That makes sense because we're not adding on or subtracting anything here. Let's see our questions. Write down the value of a. There we go. We already did that. The amplitude, a equals 7. That was just our amplitude. Also, an exam tip, please, please, please double check that when they say a, it actually means the thing that they're given, because they could ask it like this. They could say, consider the function f of x equals, I don't know, b sine cx. They could change the variables, right? And so they say, write down the value of b. And you think, okay, b was the period. But actually, in this case, b is the amplitude. So just be careful with how they give it to you. Even though we mostly use a for amplitude, B for period, C for phase shift, and D for principal axis, they can sometimes shift it in the question. So you've just got to remember where things belong. But yes, that has not happened in this question, so we're good. So A equals 7. Write down the period of f. So how long does it take this graph to repeat itself before we get back to the beginning again? So going, nothing's repeated itself. Here we go. That is how long it took to do one full wave. And if I zoom in there, because I have really bad eyesight, that is pi. You see pi over there. In AISL, that's 180 degrees. So that's how long it took me to do one wave, was 180 degrees or pi. So write down the period of f. It is, you can say period equals pi. And if you're AISL, say 180 degrees. If you're not in AISL and you say 180 degrees, you will be wrong because the graph is in radians. Hence, find the value of b. So if my period is pi and I want to find b, well, to find b, I had to do 2 pi divided by my period. So that's 2 pi divided by pi, which equals, cancel, 2. Let's do it with 180 if we're in AISL. We have to find b, we have to do 360 degrees divided by the period, which is 360 divided by our period, which is 180. And indeed, that is also 2. Then find the value of pi over 12. So we would take our function. We have f of x equals 7 sine b we just found was 2. So this is our function. And we want to know for pi over 12. So 2 times pi over 12 7 sine, that's pi over 6. And pi over 6 is in degrees, that's 30 degrees. Sine of 30 degrees is a half. So it's sine times a half, which we can write as 7 over 2 because IB loves fractions. You could also write 3.5 and no one would die. Right. You guys are holding on. Let's try another one. Nothing crazy in the mark scheme here. I think due to time, I might not do this one. But again, very similar kind of question. We can see that the middle is going through like that, the principal axis. That's at 15. So I will say that, look, they've done it, what I was talking about in the earlier example. See the plus C? We're used to that as plus D. So they've been really, that's a little, maybe trying to catch you out. So they plus C. So now that would be our D. Just to make sure that you don't think, oh, C, phase shift. What is the phase shift? But C is 15. Amplitude, we might as well do it really quick and easy off the graph. Between 15 and 20 is 5, so A is 5. And we would show that the period is pi over 6, which is basically, I show that B equals pi over 6, while the period is 12, because we can see it repeats over 12. So to get B, we need to do 2 pi divided by 12, which is indeed pi over 6. So in a show that question, just a reminder that if they say show that, you may not use that in your method. You can only arrive at that answer. If you say show that, but you use that in your method and explanation, they will give you 0 marks. You have to do everything else to end up with that. So just a reminder about any kind of show that questions. Right, then, wow, this one looks pretty. Everyone's still good? This is a paper 2 question, so calculators are allowed from the specimen paper. Right, consider a function f of x that we have 5.8 sine blah, blah, blah. They have given you most of the values, so we know that our amplitude is 5.8. B, just write A, B is pi over 6. Our phase shift is -1, because that's a +1, so it's -1. And B, they haven't given us B, our principal axis. So we'll need to find that out. And, sorry, this is a little cut off. We have that our graph is between 0 and 10. They've given us that. B is a real number. Thank you. So find the period of f. All right, so period, again, to find period, let me just keep writing out the formulas. We are in terms of pi, we see that from the question. This is always very important. If they don't specify, generally use degrees, or either should work. But if you see a pi in any way, then you're in radians. So period was 2 pi divided by pi over 6. So that was our B. So we have 2 pi divided by pi over 6. Keep, flip, change, KFC. Have you heard of that? 6 over pi. Running out of space here. I'm going to do it a little bit down. 2 pi divided by pi over 6 means we times 6 over pi. Pi's cancel out, and we get 2 times 6, which is 12. Let me take that out because, oh my word. What just happened? Did I delete everything? Oh no. No, okay, thank goodness. This pen hates me. Okay, that will have to do. I'm not going to spend much time on that. Anyway, sorry, we got 2 times 6, which is 12. Okay, so we know that the period of f is 12. Now, the function has a local maximum at this point and a local minimum at this point. So again, hint, local maximum, local minimum. That probably means you're going to use the amplitude formula or the principal axis formula to find something. So which one? They want the value of b. What was b again? See, B is actually not our usual B here. I shouldn't have even used B, but I meant B because that's our usual B of maybe capital B. But here they mean what we usually have is D, our principal axis. So what we need to find B is, it's going to be max plus min divided by 2. So we want the y values here. 21.8 plus 10.2 over 2. Well, there's a nice 8 and 2, so that's 22 plus 10, which is 32 over 2, which is 16. There we go. So the value of b is 16, which is nice to fill in when we have it. 16. Hence, find the value of f of 6. So, someone was asking about how many marks questions are worth. So here, finding the period is 2 marks. Finding a value here of b is 2 marks. So very much, if you're lucky, 2 marks, because they're nice questions to get a good 2 marks. But sometimes they're worth 1 mark. Depends maybe on the question sometimes and how many there are. So, and if it's a calculated paper or non-calculated paper, but that's for AA. Find the value of f of 6. So now that we have our b, we have the whole function, which means in place of x, I might be confusing people with colors here. In place of x, we just substitute 6. And I'm not going to do that one because we've done a few substitution questions. And I want to get to this lovely one over here. So a second function, g, is given by this, where we're missing p and q. We need to find the values of p and q, and we're given 2 points. So this is just like simultaneous equations, where you have like 2x plus y equals 5 and 3x minus 6y equals 10. You have those 2 variables, x and y, and 2 equations where you need to solve for x and y with either elimination or a substitution method. So this is the same thing, but they have given it to us with sign functions. So I'm just going to write out this function again. I often find that writing these out helps to make to break them down a little bit and to see what's going on, because when you look at those like that, it's kind of like, whoa, that's a lot of pies and numbers and brackets going on. So write it out. That it's a weird like trick on your mind that I think it helps you see it a little bit clearer when you write it out. Maybe it's just me. I like to write things out. Okay, here's our function. Now it's going through these points. So I'm going to make my first equation with this point and my second equation with this point. This is worth a lovely 5 marks, but it's not actually that challenging. So let's substitute. 2.5 is my y value. Everything else we can fill in. We're just filling in y and x. My x was 3 in that case. Q we don't know. Okay, that is my first equation. Checking for any questions or comments. Well done, guys, for hanging on this far. Now, 15.1. P sine 2 pi over 9. 6 now. My x is 6. If you spot any mistakes because there's a lot going on, I'm kind of on autopilot while I copy out these equations, just let me know. Right. So now we've substituted in for each of our equations our x and y values, and now we just need to solve for p and q. Now, looking at that, you might think, where do I even begin? But if you look at this part here, there's actually no variables there. This is just a number. So for both of these, I'm going to find out what these are. They're just going to be numbers, and then I'm going to have sine of that number, and that's going to give me a number. And I'm going to actually have linear equations after this, like really nice and simple ones. So we type in 2 pi over 9. I'm going to do this all on my calculator. 3 minus 3.7, I can simplify that. Just this part, 3 minus 3.75 is minus 0.75, and 6 minus 3.7 is 2.25, correct? That's one, yeah. So that's just the brackets part. All right, so I want 2 pi over 9. Oop. Two pi over 9. And I want it to multiply it by minus 0.75. So I'll just take that again. Times by minus 0.75. And I wanted sine of that. I might as well do it all in one go. This was a paper 2 question, right? Yeah, thank goodness. Times, so the sine of that. So let me just, I want trig sine of answer. I should be in radians. Radians. Let's try that again. Oh, look at that lovely answer. Minus 0.5. See, that's way nicer. So that was for equation 1. I'm going to simplify. So I write again, 2.5 equals P. Now I've just found that this whole thing is a lovely minus 0.5. It was negative, wasn't it? Yeah. Plus Q. Oh my word, that's already looking way simpler. So I'm going to rename this as equation 3. Do the same one for this one. 2 pi over 9 times 2.25. 2 pi over 9 times 2.25. And I want the sine of that. So notice I'm not taking these rounded values because they're going to possibly interfere with my accuracy. And I wanted the answer, previous answer. 1, how lovely. So 15.1 equals P times 1. That whole thing is just down to 1 now. So P times 1 is just 1 plus Q. So that's my equation 4. And now I have 2 linear equations that are much simpler. So if you're at AISL, you can put them in, it's freezing. You can put them in solve system of linear equations, and there you'll be able to get your values of P and Q. I'm just going to solve them now. So we're going to subtract equation 4 from equation 3 because it's good practice with simultaneous equations. 4 minus 3, 15 minus 1 minus 2.5. Done that already. And I had Q minus Q. And then I'm going to have P minus minus 0.5P. Let me just write that. I didn't simplify that further. Minus 0.5P is what that should look like. So P minus minus, because I'm minusing them, 0.05 means I'm going to have 1.5P. And Q minus Q, they disappear, which is what I wanted. So now 12.6 divided by 1.5 equals P. What is that? I think I did that already to save time. No, I didn't. 12.6 divided by 1.5. 8.4. Okay, P is 8.4. And to find Q, I just have to do 15.1 equals 8.4 plus Q. You're not even going to believe it. Q is 6.7. Love that for us. You guys too old for this or no? Something I hear like probably 5 million times a day in the classroom. So there we go. We have P and Q. Those were our values. That was quite a long question, but it was 5 marks. And it was more, I think, just algebraic solving than actual real tough maths. Remember that you can solve these once you have them linearly, especially for AISL, in your equation solver, simultaneous equations, systems of linear equations. I think that's what it's called. Solver, so that saves some time there. But don't be scared by these. They're actually, it's just a number. So once you put it in your calculator, it takes care of it. And it got numbers like -0.5 and 1, which is way friendlier. Okay, there we go. I think that was all. Yes. Kept you a bit longer. Nothing crazy in the mark scheme. So very important, just some tips to make sure if your calculator is in degrees or radians. This is even for AISL. Just make sure your calculator hasn't mysteriously switched over to radians because that will mess up everything. So just keep an eye. I can see it in the top here. Check that it's radians or degrees. Just keep an eye on that. When you do the window settings, like I did, I really recommend, we want graph. Don't know why this one's coming up. I've had it with this calculator. No. Graphs. Thank you. Remember to change the window because that really helps to go to window settings and say like I'm between 0 and 24, because if you type in your graph and nothing pops up, it's because of the window settings. So it's really important that you make sure that this is appropriate and don't have it too small. So make it like within the bounds so that you can see it, like sine. So there we can see it really clearly. If I had it like in degrees, it would look like that. And then I would know everything is wrong because I put it between a certain thing. So very helpful and useful, especially if you're having to graph like in AISL papers or in paper 2s, then they might say like sketch the graph on this domain between 0 and 24. And 0 and I don't know 50. And so if you already put all of this, that your y is between 0 and 50 and your x is between 0 and 24 onto this, and that's what pops up, you have that screen and you can just immediately copy down exactly what that looks like without even having to think about it, and make sure that you have the right mode. Another tip is that you can put a table, you can add a table of values. So you do split screen table, and then it's going to give me all of these values for different things. So if you need to read off a value, you can use table of values. You can even change the step of the table. So table settings. This is useful not just for trigonometry, but for any kind of graphs. You could, if you wanted something that was like 6.2, then you go up in steps of 2 instead of like 1, 2, 3, 4, 5. You go up in 0.2s. And this goes on forever, like in this direction, forever, and forever in that direction. So this is really useful for getting values just immediately. Or questions that say find the least value of n, for example, least value of n. So you can see, okay, the least value, the least moment that it's this number is at this value. They're very useful for that. Yeah, I think I'll stop there. It's been enough. Well done for hanging on until the end. As usual, notes are here in the end, and I'll create a homework assignment for this session as well. I still need to do the one for session 6. Okay, questions? Anything you'd like to know? Thank you so much for that comment. I really appreciate that because in a webinar, it's really hard to know if I am actually making sense or helping because everyone has such different levels and are coming with different things. So that really, really is super helpful and means a lot. Thank you. Appreciate it. Any other topics that you would like to see coming up? We've already got a few scheduled. There'll be more sessions on Tuesday evening, on Wednesday evening. No, Tuesday evening and Thursday evening. Another 4 on the weekend. We're really kind of ramping them up before the Euromaths exam. Nice. I'm glad the pacing was good. That's great to hear, even if it's just one person. We suddenly went from 4 people to 6 in the last 2 minutes, so don't know what that means. Yes, kinematics is coming up. I think kinematics will be this weekend. Kinematics will be this weekend. And what would you like to see in geometry? Things like sine rule, cosine rule, area of a triangle rule, or Voronoi diagrams, or what else is in geometry? Yeah, if you could tell me specifically what you want to see in geometry. All right, I'll wait for a minute. If you want any of these notes from this session or previous sessions, you can not email me, but DM me at Miss IB Maths. Miss IB Maths on Instagram. And just DM me with your email address, and I can send you the folder with the link. I can send you the link to the folder with all the session notes and extra exam questions and mark schemes. All right. How do we have 7 people watching now? 3D geometry. Okay. Yeah, that one's a fun one. Yeah, we'll look at putting it on, and Voronoi diagrams. So we're really trying to do kind of like the overlap of all the courses to try and help everyone. But maybe because a lot of the things have been quite AA focused, we could also do Voronoi diagrams for AISL. I think that would be fair. Okay, cool. Thank you guys so much for joining, and well done as well. Hope you learned something new at least, and we'll maybe see you this week or next weekend for, where are we? For the other sessions. So have a lovely rest of your evening, and goodbye.